Lesson 1, Measuring Matter. So matter is anything that has mass and takes up space. So we'll talk more about mass, something we can weigh. So matter makes up all objects and organisms. But not everything is matter. So let's look and see what is matter. So pause the video and try yourself, see what you think is matter. Okay, coming back. Water is matter. It has mass and it takes up space. Light, not matter, does not have mass or take up space. But air does have mass and take up space. Sound, no. Heat, no. Wood, yes. A carbon atom, yes. Doesn't have much matter, but it does have mass and takes up space. Energy, does not. Gravity, no. Tree, yes. Time, no. A rainbow, no. We can see it, but it doesn't have mass or take up space. An atom is the smallest unit of matter that cannot be broken down by chemical means. And we'll look more at that later in the semester. And that comes from the Greek word atomos, meaning cannot be divided. So how do scientists describe matter? Well, they collect data, information about matter. They can collect numerical data, which is also sometimes referred to as quantitative, talking about the quantity. So for example, you could take the temperature. You might say something's 25 degrees Celsius, or measure the length, 14 centimeters, or maybe measure the volume, 80 milliliters. Some things cannot be described with a number. You can only describe the characteristics. We call those categorical data, or sometimes qualitative data. Some examples, you might say something is blue, or describe the texture, say it's soft, or the smell. You might say it smells like rotten eggs. Those are all things that we cannot give a number to, so they're categorical. So scientists use the Système International des Unités, it's French, SI units, otherwise known as the metric system. So let's look at some examples here. We have mass, which is a measure of the amount of matter in an object. And the SI unit for mass is grams. Weight is the downward pull on an object due to gravity. And the metric system unit for weight is newtons. The English unit, what we use in the United States and England, is pounds. How many pounds something weighs. Volume is the amount of space an object takes up. And the SI, or metric system unit for volume, is the liter. The English units, there's all kinds of different things. Gallons, or if you're measuring the volume of something small, you might say teaspoons or cups. Ounces. No, ounces is weight. Fluid ounces. Anyway, lots of different ways. But if you're a scientist, you're always going to use the metric system, the SI system. So we might want to find the volume of this rectangular prism. And if you remember from math, finding the volume, let's write the formula for the volume, is the length times the width times the height. So for this particular prism, the length is 8 meters. The width is 2 meters, and the height is 5 meters. We're going to multiply those together. I might multiply these two first. 5 times 2 is 10. 10 times 8 is 80. So that's 80. And then our units, we've multiplied meters times meters times meters. So that's going to be meters to the third power, or meters cubed. So volume is a three-dimensional measurement. So that's why our unit has 3 dimensions. It's meters to the third power, or meters cubed. or cubic meters. So we talked about this. Pause the video and see if you can answer these on your own. Mass is the amount of matter in an object. So like how many, kind of measures how many atoms are in there, or how much those atoms, how dense those atoms are. But weight is the downward pull on an object due to gravity. And the moon's gravity is 1/6 of the gravity of Earth, because the moon is only 1/6 of the mass of Earth, so it exerts less gravitational pull. On Earth, 1 kilogram has a weight of 2.2 pounds. If we use the English system, it could be newtons as well. We could use that if we were using international system, SI units. On the moon, if we were to weigh a kilogram weight, it would weigh only 0.37 pounds, because I'd do 2.2 divided by 6. I would get 0.37. So, for instance, if a person who was 150 pounds were to go to the moon, we would have to divide their weight by 6. That person would weigh only 25 pounds on the moon. So a person has a greater weight on Earth than on the moon. But they have the same mass on both the Earth and the moon, because mass is just the measure of the amount of matter in an object. And the amount of matter in an astronaut's body does not change when they go to the moon. They still have the same number of atoms making up all the bones and tissues in their body. So their mass has not changed, but their weight is different, because the moon is exerting less gravitational force on their body. So you're going to look these up online to fill in these units, but I'd like you to first do the Rainbow Liquids and Metric System Virtual Lab. It's on the Google Classroom, because there's some predicting and finding out about that, and then you can come back and fill this in on your note sheet. Notice here that the base units for mass is a gram, right? This is the same as what we filled in on our page here. Mass is gram. Oh wait, we don't have that on there. Volume is liter. So here we have the mass is a gram, length is a meter, volume is a liter. And then we're figuring out, when we add this prefix, milligram, millimeter, milliliter, or kilo, or centa, how does that change the amount of matter in, not the amount of matter, how do those convert to each other? So you can look at the meanings of the prefixes. A milli means 1/1000th, a centa means 1/100th, kilo means 1/1000th. I am going to give you this one. A milliliter is the same as 1 cubic centimeter. So if we take, you might have seen these in math class, the little tiny plastic cubes we use here. Those are each 1 centimeter by 1 centimeter by 1 centimeter. So length times width times height. So for the volume measurement, that would be 1 centimeter cubed. And those little cubes are also exactly 1 milliliter in volume. And that is by design. When scientists were making up this system, the metric system, they said, well, let's make the unit of volume such that a milliliter is equal to 1 cubic centimeter. That's how we got that. Okay, that's it.